10.3, inverse of a square matrix. We're going to verify that two matrices are inverses of each other. Okay, before I do that, what is the multiplicative inverse of the number 5? That's the opposite. What is the multiplicative inverse of 5? 1/5, because 5 times 1/5 is, 5 times 1/5 is 1, okay? Because 1 is the multiplicative identity. If you multiply something by 1, you get what you started with, okay? This is an important concept because there is no algorithm for dividing matrices, but we can find an inverse and multiply them, okay? And we'll talk more about that here in just a little bit. So if I have a matrix and I know what its inverse is, if I multiply those two matrices together, I will get the identity matrix. The identity matrix is the matrix version of the number 1, right? The diagonal of 1s, that is the identity. We're going to use Gauss-Jordan elimination to find the inverse of a matrix. There's a formula to find the inverse of a 2 by 2 matrix. And then we'll use inverse matrices to solve systems of linear equations. Okay. So before we jump into what this thing is saying, if I told you that AX equals B, and I told you solve for X, I want X by itself, what would you do? Divide this side by A, divide this side by A. That means that X is equal to B over A. Okay, is there another way to do it without dividing? AX equals B. Dividing by A is the same thing as multiplying both sides by 1 over A. Y'all agree? And if I do that, the A's cancel and I get X equals B over A. Right? Okay. The other way to do it is right there in the middle. If I have AX equals B, I can multiply both sides by A to the minus 1 power. A to the minus 1 power is an inverse. How do you do this math? If I have A to the first times A, what does that equal? And why? That's a negative 1. Huh? Why? Yeah, there is a 1 here. And if you're multiplying two things, if the bases are the same, you add the exponents. Negative 1 plus 1 is 0. And what is A to the 0? Anything to the 0 power is 1. So that's what's happening here. So if I multiply both sides by A to the minus 1, A to the minus 1 times A is A to the 0, which is 1. So I have X equals A to the minus 1B. How do you get rid of negative exponents? You drop it, right? So this A has a negative exponent on it. If I want to turn this negative 1 into a positive 1, I would write it on the bottom, and there it is. Are y'all good with this? That all three of these are exactly the same? This is how we have to do it with a matrix. Let me point something else out. Notice when I did this one over here, I multiplied the left side by 1 over A, and I multiplied the right side by 1 over A. But notice on the left side, 1 over A is on the left, and on the right side, 1 over A is on the right. You cannot do that with a matrix. Because remember, in a matrix, A times B and B times A aren't the same. Okay? Notice how they wrote the inverse here. When they multiply both sides by A to the minus 1, notice they put A to the minus 1 on the left on both sides. You must do that on a matrix. Okay. The number A to the minus 1 is called the multiplicative inverse of A because A to the minus 1 times A is equal to 1. Questions so far? Besides that one.
I don't see why.
But I'm seeing Z's over there. Huh? Okay, the definition of the multiplicative inverse of a matrix is similar. If A is an n by n matrix, notice we're talking about a square matrix, right? For a matrix to have an inverse, it must be square. If it's a rectangular, or if it's non-square, there's no inverse. I sub n is the n by n identity matrix if there is one. Not all matrices have an inverse, even if it's square. A times A inverse is equal to I, which is equal to A inverse times A. Wait a second. So matrix A times its inverse is the same thing as the inverse times A. You can switch them. If they're inverses, yes, you can. Only if they're inverses will you get the same answer. And that answer is going to be the identity matrix. So if this is true, then A inverse is called the inverse of A. The simple A inverse is read A inverse. In case you missed into that. Here are two matrices, A and B. Show that these matrices are inverses, which means, does A times B get the identity? And does B times A get the identity? Yes, you must check it both ways. Okay. So let's do A times B. Matrix A times matrix B. Matrix A is -1, 2, -1, 1. Matrix B is 1, -2, 1, -1. How do you multiply matrices? Row by column. Okay, so I will do that. Row 1 times column 1 gives me -1 times 1 plus, yes, plus 2 times 1. Don't forget those plus signs in there. Now I need row 1, column 2, -1, -2, plus 2 times -1. Row 2, column 1, -1 times 1, plus 1 times 1. Row 2, column 2, plus okay. Let's take a look at row 1, column 1 here. -1 times 1 is -1. 2 times 1 is 2. -1 plus 2. One. Next one, -1 times -2, +2. 2 times -1, 2 and -2. Row 2, column 1, -1 times 1, -1, 1 times 1, -1 and 1. And finally, -1, -2, +2, 1 times -1, 2 minus 1. Is that the identity? Okay. I wanted to do that just to practice again multiplying matrices. Okay. Do what? Okay. I'm not going to do the B times A, but I'm going to tell you if I switched them and multiplied them, I'm also going to get the identity. Okay. So there's A times B. I got the identity. There's B times A, already worked out. Got the identity. So this was an example of a matrix that does in fact have an inverse. Note, not all square matrices have inverses. Okay. You can't get to the identity. You don't get the identity. You don't, yeah,
Which,
you don't get that.
like, if it has a number above or below the one, yeah.
Yes. Or maybe this number was a 2 and this was a 1.
So it's automatically like, okay.
Yep, no inverse.
But if you said like 1 is like the second one.
I can honestly not think of a situation where that's ever happened.
You don't get to-
But you're supposed to do it both ways. But I've never seen a situation that doesn't work. Is there one? There might be. Research it. Give me an example. Answer the question for us. Okay. If matrix A has an inverse, then A is called invertible or non-singular. If it does not have an inverse, it's called singular. A non-square matrix cannot have an inverse. Does a 2 by 3 matrix have an inverse? Never. Okay. How about a 3 by 4?
No.
Never. 4 by 4?
Yes.
Could. Or maybe not. Okay. To see this, note that when A is an order of m times n and B is of order n by m, where m and n are not equal, the products AB and BA are of different orders, right? Because you should understand what I'm saying. Not all square matrices have inverses. If it does have an inverse, then that inverse is unique. So if there is an inverse, there's only one. For instance, what's the multiplicative inverse of 5? 1 over 5. Is there another one? That's it. It's unique. Same with matrices. If there's a matrix, if there's an inverse, there's only one inverse. There's not more than one. That's it, just one. Okay, moving on. Find the inverse. Okay, if you are following along on the notes that are posted, this problem has a bunch of x sub 1 1s, x sub 1 2s, x sub 2 1, and x sub 2 2. I'm not going to work it that way. I'm going to work it differently. Here's the problem. I've got matrix A, which is 1 4, negative 1, negative 3. I want to find the inverse such that when I multiply A times X, I get the identity. Do we know what matrix A is? Matrix A is 1 4, negative 1, negative 3. Do I know what the identity looks like? Okay, it's not going to change. Do I know what X is? I don't. But is it a 2 by 2 matrix? Does this 2 by 2 matrix have 4 items in it? Do you know what they are? I don't. Could some of them be the same? Do they have to be the same? Okay. I don't know what this one is. I don't know what this one is. I don't know what this one is. And I don't know what this one is. I have 4 variables. Okay. Let's multiply this. What is row 1 times column 1? A plus 4C. Guess what that's going to equal? Any ideas? 1. Okay. We're making equations. Well, we're making a matrix. We're making a matrix. I'll turn it into equations in a minute. Let me get rid of that. Thank you.
Okay, I was like,
Let me undo that. Right now we're just multiplying. I'm getting ahead of myself. Thank you. Now let's do row 1 times column 2.
B plus 4B.
B plus what?
4B.
4D.
Oh my God. I'm sorry.
Okay. Let's now go to row 2. Row 2 times column 1.
-1. -3C.
Row 2, column 2. That matrix is equal to 1, 0, 0, 1. Okay. This column is equal to this column. First column goes with first column, which means I can actually convert this into a system of equations now. So A plus 4C is equal to 1. Negative A minus 3C is equal to 0. Can you solve that system? Use elimination is real nice on that, isn't it? A is gone. 4C minus 3C. C equals what? Well, if C equals 1, can you tell me what A is? C is 1. That gives me A plus 4 equals 1. A equals -3. Let's do the other system. I have, change colors real quick. B plus 4D equals 0. Negative B plus 3D equals, it's clearly a minus. Can you not read what it says?
I thought you wanted.
I don't know what you're talking about. That's clearly a minus. Can you tell me what D is? Okay. Can you tell me what B is?
-3.
-4. Okay. Guess what matrix X is? A is
-3.
-3.
B is -4.
Okay. C is
1. And D is 1.
this, folks, is the inverse to this. If I multiply these two matrices together, I'm going to get the identity. Okay. Moving along. Okay, so the next slides are going to have some more information about the same problem. We're good. Okay, here's what we had. We've already done this part. Those were our equations. We solved it. That's what we got. Moving along. There's the second one. That's what we got. Now that we've got what we claim X is, what would our next logical job be? Check your answer. Take A times X and then X times A and make sure you get the identity both times. Okay. They tested that one. It works. They tested the second one. It works. And that looks like that would be a good place to stop. And we'll, oh, that was nice. It doesn't work that way. Okay, yeah. Sometimes a matrix will look like that, but not always. All right, Parker.